Now then, we're back to radians part 3. And as you'll remember, we had this radius here, which had the coordinates of 1, 0. And we had this radius here, which has the coordinates of 0, 1. And what we're trying to do is find the coordinates of x, y, because we said that this arc here and this arc here are both the same size. Now, in the last video I said that x equals y. Now then, as we know, the distance of x is between here and here. The distance of y is between here and here. Now this is all based on Cartesian coordinates, which I covered in a previous video, and if you don't remember that, go back to my video about Cartesian coordinates and you'll figure this out. Okay? So now we have this distance, which is x, this distance, which is y. And as you know, in the Pythagorean theorem, which was Euclid Book 1, proposition number 47, which if you don't understand that, you should go back to Euclid Book 1, proposition 47, x squared plus y squared equals the radius here of 1. Remember, I said this was a unit circle, and this had a radius of 1 unit. Regardless of what unit you're using, whether it be inches or centimeters or miles, doesn't matter what unit you're using, as long as it's one of something, that's a unit circle. Okay, so we have x squared plus y squared equaling 1. That's where we get this. Now we said that x is equal to y, so if we substitute x for y, x squared plus x squared equals 1. 2x squared equals 1. If you divide both sides of the equation by 2, you get x squared equaling 1/2, and x equals the square root of 2 over 2. Okay? And that's where we get all that. Alright, so the coordinates of x and y, because x and y are the same value, are as follows. There's the coordinates of x and y. Now, do you see why we have to start using radians at this point? Because that's messy to be using in an equation. Instead of saying that we've got the plotted points at square root of 2 over 2 and the square root of 2 over 2, we can just say pi over 4. So this point is at pi over 4 instead of this. This is easier to read than that. That's why they started using radians. Okay, now, as for a wrapping function, we're going to talk about that in my next video, so stay tuned.